Hello, how do we graph rational functions? Well, here are the steps. Write these down. Find x and y intercepts, find the horizontal asymptotes, those are these asymptotes right here. Then find the vertical asymptotes, and this will split the graph into regions. See, this one has 3 regions. And then we're going to find and plot 2 extra points in each region. So once we have these regions separated, we'll just find a couple points inside of here, plot them, and connect them to sketch the graph. So let's look into each step. First, let's look at finding x and y intercepts. To find an x-intercept, we'll set y equal to 0, and vice versa for a y-intercept, we'll set x equal to 0. The first thing that we want to do, though, is simplify this and check for any holes, those removable discontinuities. All right, so here I've simplified this function, but nothing cancels out, so there are no holes. Also, let me just say I'm sorry if at any time you hear my cat in this video. She keeps walking around purring. All right, so let's get right back to this problem. 3x squared minus 3 over x squared minus 9 reduces to this, and we're going to find the x-intercept and the y-intercept. So, very first thing for x-intercept, set y equal to 0. Well, whenever we do this, check this out. If I multiply both sides by the denominator, 0 times the denominator causes it to go away. So now I have 0 equals 3 times x plus 1, x minus 1. Divide both sides by 3. Well, 0 divided by 3, that just goes away. So I get x equals negative 1 and positive 1, giving me x-intercepts at negative 1, 0, and 1, 0. Now we have to be careful because it's not always this easy, and I'm going to show you an example of that in a second. Alright, so on to y-intercepts. Set all of the x's equal to 0 and solve for y. So once you've replaced all the x's with zeros, you see that this would be 3 times positive 1 times negative 1, which is negative 3, over 3 times negative 3, negative 9, which is positive 1/3. So we have a y-intercept at 0, 1/3. So this is x-intercepts, y-intercept. Now something to watch out for is if you don't have just a fraction, like if you have like a minus 2 here on the outside, and you're solving for the x-intercept. Remember, that's whenever you set y equal to 0 and solve for x. Well, this time, we're not just going to multiply by the denominator because we have this extra 2 hanging out. So we're going to move the 2 over, and now whenever we multiply both sides by the denominator, it doesn't just disappear. Now we end up with 6 plus 2x equals x. So we'd have to solve that 6 equals negative x, so x equals negative 6 in this case. It's really just an extra step. Nothing too scary, it's just something that you got to watch out for. Alright, let's go on. Alright, the next part is finding the horizontal asymptote. And there are 3 rules for the horizontal asymptote. If the degree of the numerator is less than the degree of the denominator, like for example here where you have an x to the first over an x squared, these have a horizontal asymptote at y equals 0 every time. Alright, now if the degree of the numerator is equal to the degree of the denominator, so let's say we had 3x squared plus 7 over 2x squared minus 5. This horizontal asymptote will be at y equals, and then you just look at the coefficients. So this is going to be at y equals 3 over 2. But again, that's only whenever these degrees match. In general, we say that the horizontal asymptote is at y equals a over c. A and c being the coefficients of x. All right, if the degree of the numerator is greater than the degree of the denominator, so 3x squared plus 7 over x minus 2, where this is power 2 and this power 1, this has no horizontal asymptote. These have different types of asymptotes that we'll talk about at a later time. All right, here's some for you to try on your own. Find the horizontal asymptotes of these 3 examples, and then we'll check. I'm giving you some time. Just a little. All right, hopefully you saw that these degrees are the same, so 2 over 4 is 1/2. This degree is smaller, so it's at y equals 0. This degree is larger than the denominator, so no horizontal asymptote. All right, vertical asymptotes. Those come from dividing by 0. We've seen that all year. All we have to do is set the denominator equal to 0 and solve. So here's back to that very first example that we saw. By now, we should know where the horizontal asymptote is. We'll just list that real quick. Horizontal asymptote is at y equals 3 for 3 over 1. All right, but the vertical asymptotes, we're going to set the denominator equal to 0 and solve. You could either do this by factoring or just by solving using square roots. X equals plus or minus 3. Now, horizontal and vertical asymptotes are lines, and they must be labeled that way. Notice a horizontal asymptote is always y equals a number, and vertical asymptotes are always x equals a number. Okay? You have to label them that way. All right, now let's plot everything plus some extra points. So here's the function that we've been mostly dealing with. We're going to plot the x-intercepts and y-intercepts first. All right, next we're going to plot the horizontal asymptote at 3 and the vertical asymptotes at negative 3 and 3. Whenever you have rational functions that are split into 3 sections, for this middle section you want to pretty much plot out 3 points. And the reason for that is because in the middle of these graphs, they can actually break the horizontal asymptote. So these 3 give us the shape that we need to see. So these show me that this graph goes something like that. Now, how are we going to find over here in these spots? Well, we're just going to have to plot some extra points. To do that, we can just use a calculator. Okay? So here, I knew my vertical asymptote was at negative 3, so I found 2 points to the left, negative 5 and negative 4. And now I can plot those. Negative 5, we're at 4.5. And at negative 4, we're at 6.43. And that actually mirrors on the other side. At 4, we're at 6.43. And at 5, we're at 4.5. Now I've got plenty of points that I can see the shape of this graph. So I'm just going to connect. I'm going to get real close to the asymptotes and just connect through the points. And there we've done it. We've graphed a rational function. All right, goodbye.